I'm going to start by talking about it graphically so that we can have a conversation about like domain and ranges, because that's really important to what an inverse trig function is. On the very first slide that I show you, you probably don't have to write anything down. It's good to just kind of be like looking up at the screen, thinking about what we're talking about, because we're going to apply this rule to our inverse trig function. So on the next slide, you really don't have to copy anything down. I'll tell you the slide we get to after that when you should start jotting a few things down about inverse trig functions. I'm going to start with the three basic graphs, sine, cosine, and tangent. And here I've got y equals sine of x. Okay. I know that it's a little bit hard to see the scale from far away, but basically you're seeing a portion of it from negative pi to pi right there. I'm going to ask you this question. Is y equals sine of x a function? Blake is saying yes. Do you have an argument for why? It passes the vertical line test. Thank you very much. So if I provide a picture of a graph, you can determine whether or not something is a function by checking to see if it passes the vertical line test. If we pass a vertical line test over the sine wave, it will cross only a single point at every value of x, and therefore fits the definition of a function, which is every input has only one output. Okay, so it is a function. Now, this is going to stretch your brain all the way back to semester 1, chapter 1. Do you remember the test to determine if the inverse is a function? Horizontal line test, right? So vertical line test tells you if that's a function. Horizontal line test tells you if its inverse is a function. If we did the horizontal line test for y equals sine of x, you would say, no way, Jose, right? Okay, definitely not passing the horizontal line test, so its inverse is not a function. But notice the title of our notes today, notes 4.7, is inverse trig functions. So we want to look at just a portion of the graph, and we're going to try to identify a portion of the sine graph that will in fact pass the horizontal line test. Now, there could be lots of different sections of the sine graph that will pass the horizontal line test. We're going to be focused on a section of the graph around 0. So we want to include 0 always in our inverse trig function. Okay. So if I move to the right from 0, I've got all these values up here, and then I hit positive 1. And if I kept going past pi over 2, I would start repeating the same things, right? I'd be going down that mountain or down that hill. Would that pass the horizontal line test? If I colored in that other part of the hill? No, it wouldn't pass the horizontal line test. So I can't keep going past pi over 2. So to get all the possible values of the sine function, I've got to kind of backtrack from 0. And I would go all the way to negative pi over 2. So I'm going in between negative pi over 2 and positive pi over 2. Does that small section of the sine graph pass the horizontal line test? Yes, it does. So that's the section of the sine graph for which we're going to take all those points, switch x and y, and regraph, and that will be our inverse trig function, that little section. Okay. Now, the domain of this section that I have highlighted here starts at negative pi over 2 and goes to pi over 2. Should have bracket there. The range of that section of the function is our lowest value for sine, negative 1, to our highest value, which is positive 1. So negative 1 to 1. Remember that if we take that graph, that's sine, and we would graph its inverse, we would switch the x and the y, which effectively switches domain and range. So this is going to be super important on the next slide, and you'll write this down. When we talk about inverse sine, these things will be switched. So the domain for the inverse sine function will be any value from negative 1 to 1. That represents the ratios of opposite over hypotenuse. The opposite side of a triangle can never be more than the hypotenuse, so it should never be more than 1 or -1 or less than -1. And the ranges, this is going to be the other important thing, are going to be that domain, -π/2 to +π/2. So I will only accept answers from you when we're talking about inverse trig functions within that range, -π/2 to +π/2. Okay, we'll talk about that on the next slide. Now, we're going to look really quickly at cosine. Okay. And I'd sort of do the same work that I was doing with sine, which is I want to include 0. Okay, so I'm going to start up here at 0, 1 on the cosine graph. I'm going to move forward, and I get to π/2. If I keep going, will I still be passing the horizontal line test? Yeah. Okay, so I'm going to keep going. Okay, right here. And so when I look at cosine and I look at the section for which I want to look at for the inverse, I'm going to have the same range, -1 to 1, okay, which makes sense because it's adjacent over hypotenuse, and the adjacent can never be more than the hypotenuse. But the range is going to be different, the domain is going to be different. The domain is going to go from 0 to pi now. So this means that when we look at the next slide and we talk about inverse trig functions, if you're doing an inverse cosine, you should only answer angles between 0 and pi. So angles that are not between 0 and pi are not acceptable answers to an inverse cosine function. And the last one is, of course, tangent. Okay. We're going to think about tangent much like we do in the framing method. We want to include the 0. Okay. And I could like hop over π/2 and then grab those negatives, but wouldn't it be nicer just to have one nice smooth curve of the tangent graphs? Okay, so I'm going to include, just like I did for sine, I'm going to go to the right of 0 and I'm going to go to the left of 0. What do we know happens at -π/2 and π/2? You have some vertical asymptotes there. Okay, so that would change for this section of tangent that I'm looking at. I would say its domain is -π/2 to +π/2. And its range is from -∞ to +∞. So we know that as we get closer and closer to that π/2, our tangent branch is just getting closer and closer to that asymptote and increasing towards +∞. So when we switch these for the inverse, what that means is you can put any ratio, any number that you want in for tangent. -∞ to +∞ will be your new domain. But the answers that you give me will be just like the answers to sine. They can only exist between -π/2 and +π/2. Okay. Here's what you need to put down in your notes. Basically, on the left, with the inverse trig functions, I've got the two sets of notation, and this will be similar for each one. You are probably most familiar with that sign with the -1. Okay, that's what's on the calculators. And I think if you did inverse trig functions at all in geometry, you would have written them as that. When I read that with the -1, I just say inverse sine. The other notation, which you may be familiar with from Algebra 2, is the arc sign. And so arc sign means the same thing. You can say inverse sine or arc sign. We mean put in a ratio, get out an angle. Okay, so that might also be something that on this very first one you add into your notes. You are inputting the ratio. You get out the angle. So if I know the ratio of the two sides on the triangle, if I know the opposite over hypotenuse, I can do the arc sine of the opposite over hypotenuse ratio, and that will tell me what my angle is. Also really important on the other side is going to be domain, -1 to 1. and range negative pi over 2 to positive pi over 2. Now, something that I think is really helpful when I'm trying to do inverse trig functions and I'm doing it without a calculator, okay, I think about that range where I can answer visually. So think about a coordinate plane. Think about angles in standard position. So you have initial side on the positive x-axis. If your range is from negative pi over 2, that's the negative y-axis, to positive pi over 2, that's the positive y-axis. The angles that you name for your solutions to inverse sine should only exist in quadrant 1 or quadrant 4. And those angles have to be between the negative pi over 2 and the positive pi over 2. So when you're down here in the fourth quadrant, you could say negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6. You do not use 11 pi over 6, 5 pi over 3, 7 pi over 4, 3 pi over 2. Okay, so that's probably going to be the biggest place where you could trip up, is you name one of those angles that isn't in the range. For cosine, the only thing that changes is, of course, the notation changes to inverse cosine and arc cosine. And then, of course, the range will change. So on that graph of cosine, we highlighted the section of the cosine graph from 0 to pi as our domain for our inverse, or sorry, as our domain, which would be the range of our inverse trig function. So now when I think about answering inverse cosines, I'm answering from 0 to pi. So I can answer any of the angles in the first quadrant. And then when I get to the second quadrant, I'm answering things like 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. And the last one is tangents. And I've got a couple of little typo there. These should be parentheses. Tangent's a little bit different in that we don't have as big of an issue with our domain. You can put anything you want into tangent. Negative infinity to infinity for your domain. The range, a little hard to see when I made my parentheses, but that's negative pi over 2 to positive pi over 2. And so the visual for what angles you're answering is the same as sine. You're answering the same angles in quadrant 4 or quadrant 1. If your ratio for your inverse tangent that you're putting in is positive, you're going to answer one of those angles in quadrant 1. If the ratio is negative, then you know to answer one of the angles in quadrant 4, but you answer them within the range negative pi over 2 to pi over 2. Okay, so we're going to do a few examples here. The arc cosine of square root 2 over 2. I'll walk you through my thought process here. I'm thinking about arc cosine, and immediately what pops into my head? Quadrant 1 and quadrant 2. My range for arc cosine, my answers can come between 0 and pi. If the ratio that I'm given is positive square root 2 over 2, then I must be in quadrant 1. And which angle has square root 2 over 2 in quadrant 1? Pi over 4. So without a calculator, I answer. The other thing is that we default to radians. So our answers should be given in radians when we do inverse trig functions. Okay, next thing I want you to do is stand up. Everybody stand up. Walk at least 10 steps and find a partner. Walk at least 10 steps.
Oh, hi, how are you?
Okay, pair up with somebody. We'll see who needs a partner. Nick needs a partner.
Brother and sister.
Emily needs a partner. Kirsten needs a partner. Do I have an odd number of people today? Okay, so we always have one trio. Kirsten, you can jump into any trio that you like right now. Okay, so I would like for you to have a discussion with whoever you're with. What is the arc cosine of square root 3 over 2? And kind of walk yourself like, what are you doing? What are you thinking? David, do you have an answer? Power 6. So you're thinking this is a positive ratio, so we know that all of our answers that are positive exist in quadrant 1. And the angle that has a cosine of square root 3 over 2 is power 6. Okay, find a new partner. Walk around real quickly, find a new partner. Anybody? You know, take 5 steps or something like that. Move around a little bit. Don't be shy. Find a new partner, and I should have one trio. Faith, you can join anybody you like. Okay? Arc sine a negative 1/2. Okay, Bruin, do you have an answer? Oh, are you talking about it? Okay, so what are you thinking about right now? It must be in the 4th quadrant. So if you imagine arc sine, remember arc sine happens in quadrant 1 or quadrant 4. We must be located in the 4th quadrant. And you're going to think about which angle has a sine value of negative 1/2. So you're going just down a half, right? What angle is that? It's 11 pi over 6 on the unit circle, but can we answer 11 pi over 6? It is not within the range of negative pi over 2 to positive pi over 2, so what are we going to answer? Negative pi over 6. Does that make sense? It has to be from negative pi over 2 to positive pi over 2. So you've got to change it into its negative angle equivalent. Okay? Walk another 8 steps and find a new partner, please. Okay, do I have a trio somewhere? Who's my lone wolf? Oh, okay, Joe, join any trio that you like. Okay, excellent. I'm going to have you guys talk about 2. Arctangent of 0, arc cosine, or inverse cosine of negative 1/2. Okay, Hannah, do you have an answer for arctangent of 0? 0? Yes. Between negative pi over 2 and positive pi over 2, where is tangent equal to 0? At angle 0. At negative pi over 2 and positive pi over 2, it's undefined. Okay. And Jordan, do you guys have an answer for inverse cosine of negative 1/2? 2 pi over 3. What do you guys think about that? Raven says? Yeah. Joe is thinking about inverse cosine happens in either quadrant 1 or quadrant 2. If it's negative, it must be in quadrant 2. And so you're thinking about which angle has a cosine or an x value of negative 1/2. That is 2 pi over 3. Okay, so I agree with that. That's between 0 and pi, so we're okay. Okay. Excellent. Find one last partner. One last partner. Okay, can I have one trio? Do I have 2 trios? 3 trios? Arcsine 2, inverse tangent negative 1.
That would be. Okay, Nick, what do you guys say for arcsine of 2? Why not? Did anybody else have a hard time with arcsine of 2? Why? There is no sign value of 2 on the unit circle, so this is not possible. Notice that 2 is not within the domain of negative 1 to 1. It is impossible to have opposite over hypotenuse be a 2 to 1 ratio. Then your opposite side would be longer than your hypotenuse? Okay, not possible. Raven, what did you guys say for inverse tangent of negative 1? Not possible.
Can tangent equal 1 or negative 1?
Yeah.
Yes, it can.
No, it can't.
Okay, let me ask you this. If tangent was negative 1, in which quadrant must you be in?
Fourth.
In the 4th quadrant. Is there an angle where the opposite and adjacent, or the x and the y, would be the same? 7 pi over 4, but we cannot answer that. So we have to say negative pi over 4. Okay, give your partner a high five and go back to your seat. Yes. Okay, so you have to be, when you're doing inverse trig functions, you have to be thinking about many things. First of all, you got to know your unit circle still, okay? And you'll need your unit circle for your test next week, so make sure you're studying and reviewing that as well. You also need to be very conscious about like your domains and ranges. So when we go back to that previous slide, when I asked that really challenging question about arcsine of 2, that's not within the domain of arcsine, so it's not possible for you to be able to give me an output on that.
Okay, so I have to give you ratios that are between -1 and 1 in order for you to be able to do an arc sine. Okay, same thing would be like that whole issue of answering within the range specified. So you're either in quadrant 1 and 4 for sine and tangent, or quadrant 1 and 2 for cosine, and you have to give the angles within those ranges of -pi/2 to +pi/2. So on that very last one, someone had said 7 pi over 4. But even though that's in quadrant 4, it's not within the range of -pi/2 to +pi/2, so we have to use the negative angle value, -pi/4. Okay, that's different than if I just say, like, state the two angles on the unit circle that have this sine value. Okay, so that's a different type of question when we do an inverse trig function. Got to be within the correct range. Now, I just want to say really quickly that there will be some questions on your homework that ask you to do inverse trig functions in the calculator. And what I will say about this is check your mode. The book makes a short mention of this in the text for the section. Basically, when you do inverse trig functions, your default mode should be radians. Okay, so when I say check mode, I mean you should give me a radian answer. Okay. Now, this is probably opposite of everything you've ever done with inverse trig ratios. Because a lot of times in geometry, when you're doing inverse trig ratios, you're like trying to find an angle of elevation or an angle of depression or just like an angle in a right triangle. So you probably have your mode set to degrees. So you could tell me that angle is 53 degrees. Okay. But in these calculator problems, your default mode is going to be radians. I'm just going to put up the answers, and you can see if your calculator is giving you correct values, and call me over if you're having trouble. For arc tangent of 1.9, you should get 1.086. For arc cosine of 2, you should get a domain error. That's just like arc cosine of 2, not possible. And for inverse sine of -0.919, you should get -1.166. So make sure your calculator is in working order. Okay. Reminder, default mode for inverse trig functions is radians. The book basically says the fact that the calculator has the degree doesn't make sense. Okay, we would maybe argue differently on that one. Okay, but they'll give their answers in radians. Okay, next thing we want to talk about are the inverse properties for the inverse trig functions. And we do inverse properties, oh gosh, when do we do them in Algebra 2? With logarithms, I think?
Yeah.
Okay, there are inverse properties. And the weird thing about inverse properties is, like, inverse properties are not supposed to be challenging properties. Okay, so think about inverses in mathematics. Addition's inverse is subtraction. The inverse to multiplication is division. To square something and square root it is also an example of an inverse. When we do logarithms, logarithms are the inverse to exponential. So basically the thing you should know in math about inverses is inverses are meant to undo each other. Right? If I add 3 and then subtract 3, it's like I did nothing at all. Okay. So if in the inverse property, that very first one that I have, the sine of arc sine of x, the sine is going to undo arc sine and we'll be left with x. They undo each other. Over here, the arc sine of the sine of y is y. The inverses undo each other. Okay, so if you want to, break into a sine, use an arc sine. Okay, or vice versa. Okay. Now there are some specifications to this if x is between -1 and 1, right? Because you'd be putting a ratio into arc sine, and so the ratio, just like we saw in the arc sine of 2, has to be within a special range. So as long as x is in that range. And over here for y, as long as y is between -pi/2 and +pi/2. Okay, so it would have to be special there. You can write the same two properties, but switch the ratio. So there's a cosine arc cosine of x, which is equal to x.
there is an arc cosine of cosine of y, which is equal to y. Think about, like, you're doing arc cosine in both of those, so think about domains and ranges. If you're doing the arc cosine of x first, you can only put in -1 to 1. Okay? So the value that you put into the arc cosine piece, because that's in the inside of that composition, it has to be within the domain of the original function, arc cosine. And over here, when you do arc cosine and cosine y, you can get an answer for cosine y. You can only get -pi/2 to positive pi/2 for arc cosine. So y has to be within that realm. If y is outside of that realm, you need to do the actual work. Okay, you wouldn't be able to use the property.
Sam, how about the range for cosine?
Oh, yes, sorry. 0 to pi. Thank you, Jordan. I was thinking in my head, make sure you write 0 to pi. Then I started talking. 0 to pi. Thank you. Make sure you make that correction. And then we could have the same thing for tangent. This time, x can be any real number. Doesn't matter. Because our domain there is -infinity to infinity. On y would have to be in that range from -pi/2 to positive pi/2. So I'm going to do 2 examples to show you like where you might have issues with this. And I would say most of your issues will happen on that side when you're doing the arc sine of sine or the arc cosine of cosine. And this goes back to what's allowed for your range. What are you allowed to get out? Okay? So here's one example that I'll show you. We're going to do the arc cosine of the cosine of 3 pi/4. So if I'm thinking in terms of my inverse properties, I would automatically think my answer should be 3 pi/4. In order to see if that's actually correct, check that against this range for y. Is 3 pi/4 within the specified range of 0 to pi? Yeah. So if we undo cosine by doing the arc cosine of it, we will get 3 pi/4. That is fine. Here would be one that doesn't work out as nicely for us. Arc cosine of cosine 5 pi/4. So like if I'm just thinking about the inverse property, I would probably automatically want to say 5 pi/4, right? Okay. But if I answer 5 pi/4, and I think back to this interval on which y can be, 5 pi/4 is outside of that range. Okay. So what I would be thinking about is, what is the cosine of 5 pi/4? What's the x value at 5 pi/4? -√2/2. If you have that ratio, what's the arc cosine of -√2/2? Since it's a negative ratio, you should be in which quadrant? Quadrant 2. And that angle is the 135, but we answer in radians. 3 pi/4. So notice both of these answers are 3 pi/4. So be careful. You can use this shortcut and just say, oh, they undo each other, 3 pi/4, as long as the answer fits the range for arc cosine or arc sine or arc tangent. If it doesn't fit the range for arc cosine, arc sine, or arc tangent, then you should think about, is your ratio positive or negative, and give the correct angle within those 2 quadrants. You okay with that? Okay.
So we'll look at just a couple of quick examples, and then there's one other thing we want to look at before we leave. If I did the tangent of the inverse tangent of 15, I'd immediately be thinking 15, right? Okay. If I go back and I check the arctangent, does that work out? Yeah, x can be any real number. So I'm thinking that's okay. 15. They undo each other. If I look at, arc cosine and cosine of 4 pi over 3, we already did that one, right? Oh, no, we didn't. We did 3 pi over 4, didn't we? Okay, so let's look at this one. Arc cosine of 4 pi over 3. Instinctively, using my inverse properties, I would think 4 pi over 3, right? Is that within the range from 0 to pi? No. So on this one, you need to think a little bit longer about it. If you're doing the cosine of 4 pi over 3, that's in the third quadrant, and the cosine would be negative, right? Negative 1/2. What would the arc cosine of negative 1/2 be? Which quadrant would it be in? Quadrant 2. What angle has negative 1/2 for its cosine? 2 pi over 3. That was one of the ones you did with your partners. Okay. So 2 pi over 3 would be the answer there. Sine of arcsine of pi. What's that, Jacob? It is not possible. Can you do the arcsine of pi? No, because arcsine has a domain of negative 1 to 1. Okay? The ratio must be between those two values, negative 1 to 1. You can't have a ratio that's more than 1. Pi is 3.14. So this is not possible. And one last one, real quick. The inverse sine of 7 pi over 4. Can we say 7 pi over 4? No? What would we say instead? Negative pi over 4. This sine of 7 pi over 4 is going to have a negative square root 2 over 2. If we did the inverse sine of negative square root 2 over 2, we'd be answering in the fourth quadrant. Okay, and that would be negative pi over 4. Okay, so be very thoughtful about domains and ranges. Okay, last example that we want to go through. This is going to be similar to work that we've already done, but now you're going to be thinking about quadrants in which your triangles lie. And then if you're doing arcsine or arctangent, it could be in quadrant 1 or quadrant 4. That's it. If you're doing arccosine, it could be in quadrant 1 or quadrant 2. That's it. Okay, previously, in our earlier work, we could be in any of the 4 quadrants. Okay, now we're restricted to those with arcsine, arccosine, arctangent. So if we're doing arccosine, which 2 quadrants could I be in? 1 or 2. If the cosine is positive ratio, then I must be in quadrant 1. So I'm going to draw a triangle in quadrant 1. And I know that cosine is x over r, or adjacent over hypotenuse. That would be positive 3 and positive 5. Can you tell me what the y value is in quadrant 1 then? 4. And can you now answer the tangent? Would be 4 over 3. Y over x, opposite over adjacent. Here's another example really quickly. Cosine of arcsine of negative 2/3. Cosine of arcsine of negative 2/3. So arcsine, what 2 quadrants could I be in? Quadrant 1 or 4. If my sign is negative, I must be in quadrant 4. So draw a triangle there. This would be y over r, and remember, r is always positive. If you're in that 4th quadrant, you must have a negative y value. You must went down 2 and then had a radius of 3. You can do Pythagorean theorem to find x. X must be the square root of 5. And it must be positive because you're going to the right. So you're thinking about the coordinate plane, you're thinking about coordinates, you're thinking about direction, and then can you answer the cosine? Square root of 5 over 3, and it should be positive because it's in quadrant 4 where cosine is positive. Okay, so you have a homework assignment, a book assignment, it's on the gold sheet. You should have crossed out page 336, so please don't do page 336. Okay. Also have your problem set ready to turn in at the beginning of class tomorrow. 336 can be crossed off of your gold sheet. I have it on the next slide, I can't remember. Yes, page 326 is your assignment.